Hello everyone, welcome to the channel and my name is Harshit. In this particular video, we talk about calculus for machine learning. Why you should learn calculus, how much should you know, how do machine learning models train. We cover everything in this particular video. Also, this is the first lecture of my course, Foundations for Data Science and Machine Learning. Inside that, we have a calculus module, and this is the first motivation lecture in that particular course. You should definitely check it out if you are a beginner and you're looking for something to build solid foundation in order to get started with data science or machine learning. So yeah, check out this video and I'll get you at the end of this video. All right. It's time to unveil yet another very important prerequisite for learning machine learning. Bam! Calculus for machine learning. So for those of you who don't have a clue what calculus is all about, so calculus is a branch of mathematics that studies the rate of continuous change of function through two main concepts. Those are derivatives and integrals. And that's what we are going to cover in this particular module. Now, most machine learning or deep learning algorithms perform optimization of some sort. Now, machine learning is about modeling a relationship between different features through data. Now, this relationship further relies on certain parameters. And our task here becomes to find the optimal parameters that best describes, or you can say approximates, the relationship between the features through the data that we have. Now, to find these optimal parameters, we need to minimize the loss or the error, which is represented by a loss function. A common approach to minimize the loss function is to use derivatives or partial derivatives, also known as differentiation. Similarly, integrals also help us in the calculation of area under the graph of a function. Now, this is commonly used in classification problems where we plot ROC curves. And I'm just talking about these concepts from data science or machine learning standpoint. Now, what is this optimization algorithm? What does it do? How does it work? So, optimization basically pertains to the task of either minimizing or maximizing some function f of x for different values of x. So you can say that I have y equals f of x. Now when I say I want to compute the derivative of this function, I would basically mean that I need to compute f dash x. So this is the notation for the derivative of the function f of x for any value of x. So this basically means derivative of f of x at x. Here x and y both are real numbers. Both are real numbers. So when I say what an optimization algorithm does, it basically minimizes or in some cases maximizes this particular function using derivatives. So let's say if I have to give you an example, let's say I have some function which has a graph like this. So this is, let's say, my f of x. Now f dash x basically gives me the slope at various points. Let's say this is x3, this is x2, and this is x1. So if I am computing f dash x at this particular point, so f dash x basically returns the slope at that particular point. So at this point, f dash x is going to give me the slope of this tangent. Similarly, this looks like the minimum point, or you can say here the value of y is minimum as compared to all the other points on this particular curve. So here if I compute my f dash x, so that would look something like this. So here the tangent would be horizontal. So it means that f dash x here would be 0, which actually tells us that it's a minima. We'll talk more about it as we'll dive deep into the module. And similarly for this particular point as well. So here we are computing f dash x at x3. Similarly here it is x1 and here this is x2. So most optimization problems are expressed in the terms of a function which we say f of x. In case of neural networks or deep learning, while solving any classification or regression problem, we deal with different loss functions. For example, we often use binary cross entropy function to solve classification problems and mean squared error in solving regression problems. So you don't need to worry about what those functions are, but here we are simply saying that we are trying to minimize these loss functions. And as you'll dive deeper into machine learning and different sort of algorithms, you'll get to learn more about what these loss functions or error functions are. But here we are going to see how differentiation can actually help us get to the minimum loss. So these loss functions are then optimized using an optimizer. So a commonly used optimizer is gradient descent, which is nothing but partial derivatives in action to minimize the loss. Now, depending on the number of layers, partial derivatives leverage the chain rule to first calculate the loss and then propagate these losses across each node of every layer. And this is basically, I'm giving you an example from the deep learning standpoint. Now, if you need to learn more about deep learning or what neural networks really are, I really recommend you watch this video, Introduction to Deep Learning by Alexander Amini. So this is from the MIT course. Here, Alexander actually explains in very simple words and visualizations how deep learning or how neural networks actually work right from the scratch, and how losses, how different layers, weights are actually computed and updated as we learn from the data step by step. In the module, we'll see how we can minimize the linear regression algorithm, or how we can solve the linear regression problem using derivatives. Now, the important question is, what are the essential topics of calculus that we should cover? And in this module, we'll start from understanding derivatives, how they're computed for different functions, how partial derivatives are used to compute gradients of a loss function, and how we find the local or global minimum of that particular function. We'll cover all of these terminologies. If there is anything that you do not understand, we'll be diving deep into it as we move through the module. Lastly, we will briefly talk about integrals and how they help us in calculating area under the curve. Alright, there are a lot of reasons to learn calculus now. Let's quickly get started with this module. So I hope that was helpful for you, and if it was, do check out the course Foundations for Data Science and Machine Learning by Viplayan Academy. I started this academy in order to cover these courses that would basically bridge the gap between what's required in the industry and what we are learning through these open online courses. So yeah, do check out the course. Let me know if you have any questions. Feel free to reach out. I am happy to help. Feel free to comment down below, share the video with your friends, colleagues, and fellow students. And yeah, comment, share, subscribe, help us grow this channel, and I'll catch you in the next one.